Solve the equations using substitution. Identify any extraneous solutions. We have 9a to the fourth plus 26a squared minus 3 equals 0. And we're going to let u be the same thing as a squared. And then by squaring both sides of this equation, not only will we let u equal a squared, u squared, which would be the same as a squared squared, ends up being the same thing as a to the fourth power. So we're going to take out the a squared, substitute a u, and we're also going to take out the a to the fourth and use u squared. So we're going to momentarily change the look of the problem to 9u squared plus 26u minus 3 equals 0. And this allows us to view the problem as a quadratic equation, use our quadratic methods, but then we have to remember to unsubstitute, which we'll get here to in a minute. So yes, this quadratic equation can be factored. We can factor it as 9u minus 1 and a u plus 3. If we multiply those two factors together, we will get this quadratic equation. Let's set each factor equal to 0. We have 9u minus 1 equals 0, or u plus 3 equals 0. Solving for u, we get add 1, divide by 9, u is equal to 1/9, or u is equal to -3. This is not the final answer. We have solved this equation for u. We have not yet solved the original equation for a, so we have to unsubstitute. We have to remember that u is the same thing as a squared. So u comes out, a squareds go back in. So we have a squared equals 1/9, or a squared equals -3. So now we'll have to take the square root of both sides, not forgetting the plus or minus. Square root of both sides, plus or minus, and we get a equals plus or minus the square root of 1/9, which is plus or minus 1/3, or a is equal to plus or minus the square root of -3. That ends up being plus or minus I√3. So there are our solutions. A is either equal to plus or minus 1/3, or x is equal to plus or minus I√3.